Okay, so in this video we will talk about the DDA line algorithm, which is Digital Differential Analyzer algorithm. So it is a basic algorithm basically used in computer graphics, not in the modern days, but in the starting phase of computer graphics. It helps us to generate a specific line between 2 points, right? It basically uses an incremental calculation to determine the pixels that should be illuminated to form a line, right? Nowadays, DDA is not that much in use, but it is kind of a foundation for us to understand how a line is drawn on a simple monitor of a screen of a computer, right? So, DDA algorithms basic core math is this equation, which is y is equal to mx plus c, right? This is a basic line equation in which y is equal to y coordinate, m is equal to the slope, x is equal to the x coordinate, and c is equal to the y intercept, means the line at which point it is cutting the y coordinate, right? In this, the one of the most important thing which determines the angle of the line, right, is the m, which is the slope, and it is calculated with the help of difference between y upon the difference between x, which is del y upon del x. So the DDA algorithm just helps us to find this m, right? Basically, how much you need to increment the thing, increment and each x and y coordinate, so that it will eventually reach towards the end point, right? So in this the DDA algorithm, what we first do is that we calculate a variable step, in which we see which is bigger, the del x or del y. So del x, del y are basically the difference between the initial point and the final point. So let's just say that del y is equal to y2 minus y1. Here the y2 and y1 are the initial and final points of a line, right? And similarly the del x. So whenever these two things are calculated, the difference, and whenever they are plugged it into the max function, which takes out the maximum value, whether it is x or y, and stored it inside the step value. Now, this step value then gets divided with del x and del y. So let's just say x increment, there is a step basically. So let's just say the del y is kind of big, right? So the x increment formula will consist of del x divided by the del y value, and y increment will always be 1, because del y upon del y is equal to 1. So y increment will always get an increment in whole number, and x increment could be a float integer, right? And after finding out the x increment, y increment, we just plug it into our initial coordinates, and we just increase the values of the older coordinates and just stored it into the newer coordinates, right, to get a line. And this thing moves on and on and on until we reach to our final point. So here's a very simple implementation of DDA. So here we defined the initial points as x1 and y1 as 2, 2. Let's just tweak it a bit. Let it be 15. 15, yes. Now reset it, start the animation. Yes, it's now working. So if we change it, rather than making it 10, we make it 15. So 15 minus 2, it will be 30, right? So in this we can see the del y is way bigger than del x. So here we will choose this step as 30, right? So what is the increment of y? So increment of x, let's just say first find out. So increment of x here, which we have defined in the mathematics section, is the del x upon step, right? So the del x is 8 divided by 30. You will get somewhat value in 0.0 something. That's final. And in the increment of y, you will initially get the value as 1, right? So it you can see the visually too, right? The y is kind of much more bigger. It has visually much more space rather than x. So y will move much more in whole number rather than x, right? So it's just setting out the steps, how much steps you have to take, right? So if we run it, the step by step, you can see that it is taking much more higher steps on the y to reach the end goal, right? So this was a very simple animation to work with it, and this is all about the DD algorithm, right? The next thing is the advantages and the disadvantages. One of the big disadvantage of this algorithm is that we have to deal with float values, which is kind of a no-go for us because float values are very difficult to compute, right? They take a lots and lots of space, and it is very difficult for us to store those values. And um, it's one of the biggest problem the DDA faces. And nowadays people don't use DDA; they use Breschermann's algorithm or other finely tuned algorithms to draw lines on a graphical interface, right? So this was all about the DDA algorithm. Thank you.